Well, good afternoon. Let's get involved with decimals. Now, decimals, unlike fractions, are a little bit easier. Fractions for those with disabilities and struggling learners is a challenge. Now, for individuals with disabilities, when it comes to decimals, it's not like, oh gosh, decimals are so much easier, because it's still that dot does and ones and hundreds and tens and all that definitely causes some confusion. What we need to make sure, and we can start off easily with calculators, money, and the like, students need to make sure that they see that the conceptual understanding of what a decimal is and that there's rules aligned with manipulating that decimal. And if they can understand the symbols and some of those elements of rules, we go a long way. Now, with that said, it's important for the student to understand that this decimal number is, aligned with, and they need to be actually offered this explicit connection, and generally, very concretely. But they need to understand that the decimal system is not this new symbol system representing a totally new concept. Rather than, as we know, decimals instead are an extension of an already partially mastered system of whole numbers, of fractions, and things of that nature. Oftentimes, individuals with struggling learners and those with disabilities very well may see it as something new. They'll throw out everything else, and as they grow, we'll continually seeing them making the poor connection and scratching their heads on it because of what they initially didn't make the connection for. Now, with that said, we know decimal numbers are proportions, right? Incremental units of 10. So certain manipulatives, such as our base blocks, or base 10 blocks, I should say, are quite easily the best way to represent this idea of decimal numbers. Now, taking the blocks, and we can do lots of things with the blocks, right? So we're taking the blocks, we're adding on this idea of the rods that we used a while back, of course, well, depending upon the age of the child, but oftentimes a while back. But using the 10 blocks, teachers can create activities that describe things from extensions of fraction strips, which we talked about last time we met. But in so doing, it's very concrete, and in so doing, they can also see the tens blocks as they align to tenths, hundredths, thousands, etc. And it's very, very relevant for the individual that needs to see that connection. And these continue to be used for arithmetic, multiplication, division, subtraction, and the like. So it's not something just to introduce, it's something we can continue with. Now, something we need to represent and need to recognize with individuals, especially struggling learners, is they don't see the connection. They don't see the difference with decimal numbers, and or what they start doing is they are applying what they know about whole numbers to decimals. So for example, they may look at this and say, well, 1.29 is greater than 1.4 for a number of different reasons. Because one, well, there's more numbers. That's one thing, and we'll talk about that here in just a moment. They don't make a connection with how zeros have been used in whole numbers. They actually try to apply that over into decimals, and actually they are trying to make the connection, and they're doing so inappropriately. So what we need to do, though, with these individuals is think about estimation. And we talked about estimation with fractions as well, but here with decimals as well, is having them think about this idea that, okay, so 1.29, so you got to think about the number. Have them think about process the number, and then kind of estimate in respect to 1.3. Is it about 1.3? Is 1.3 less than 1.4? What does this actually mean? These estimation activities really allow for a foundation for checking the reasonableness of the calculation, but also for the individual to better represent what the number actually is and what it represents on everything from the number line to other conceptualization. So estimation throughout this process is really, really helpful. Another aspect that can be helpful, and this is getting a little more complicated, but early activities where we have maybe base 10 blocks, but we could also use graphing paper, and that could be used for more abstract thinking here. So here they're able to verbalize the rules for lining up to decimal points. They're able to make the connection in terms of comparison. They're able to see here where the decimal points lie in terms of greater than, less than, etc. And then of course here we're also applying it as well. So lots of possibilities with the graphing. But of course back to the base 10, here students can represent multiplication and division problems involving decimals on 10 by 10 graphing paper as we have here. So using a graph to show the actual multiplication problem. So for example, let's multiply 0.7 by 0.3, which would yield us 21 of 100 squares. So a lot of different things we can do with these base 10 that allow for kind of beginning conceptualization but into computation as well. Now, when we do introduce things, we do need to introduce, as I mentioned before, everything from tenths and hundred places to smaller numbers to connecting it to real life, as we mentioned a moment ago, definitely in respect to money. Regular place values first. And so there's a number of ways to introduce these things, and very possibly your students are already there. But with that thought, there are ways very quickly to take the fraction strips that we talked about earlier and take those, and then these aren't exactly aligned to it, but the idea here is that, okay, well, so we have 1 over 1, so we have 2 over 10, so 1 over 10, 2 over 10, so okay, 1 to 10th place, so, basically we introduce that, and then we take this idea that 3, which is 3 of 10, 3 over 10, we put that in the 10th place, and then we take another strip, if maybe this one's up to 100, and we take 3 out of 100, well, now they know that goes into the 100th spot, and et cetera, et cetera, et cetera. Now, there's a number of tools I'm going to share with you with an activity. Some are Flash-based, and I know that's a limitation for you. Others are apps, but there's some very nice virtual manipulatives that allow you to do a number of different things with base 10 blocks, that allow you to start with basic computation, arithmetic, basic understanding of the decimal, and then everything up to much more extensive computation, all through these virtual manipulatives. And again, I know one of the issues is the Flash, but there are a number of apps that increasingly allow you to do that as well as Chrome apps that allow you to do that. So depending upon the devices you folks are using and your students are using, great place to practice and great place to review. All right, so let's take consideration of the following decimals, right? And let's put them in order from least to greatest. Now, in taking a look at that, there they are again, there are several things that take into consideration for struggling learner and those with disabilities. And I'm going to basically focus in on 6 of these things. So longer is larger, shorter is larger, internal 0, less than 0, reciprocal thinking, and equality. Now, let me break this down for you. First of all, longer is larger. So that's a very, very common, if not the most common error. So they judge it as they would a whole number. So 0.375 is greater than 0.97 with the logic that, 375 is a bigger number than, or larger number, or longer number than 97. Or shorter is longer. So digits for the right are very small. So, right, longer numbers are smaller. So they would choose 0.4 as larger than 97 because a tenth is larger than a hundredth. All right. So that's, okay, a consideration. The other aspect is this internal 0. Students confuse the 0 in the 10th position. So here they might say that 0.58 is less than 0.078 because they're using that same rule of the whole number where the 0 prior to the number does not make a difference. And so, something to consider. The less than 0. Less than 0 is they may compare 0.36 to 0 and they say 0 is larger. 0 is a whole number, right? Positioned in the one column, so they're not sure if the decimal is greater than 0, and therefore they think, 0 is, is bigger. Reciprocal thinking. They compare 0.4 to 0.6, and they say 0.4 is greater because they think 0.4 is, well, it's a fraction. It's a fourth, and 0.6 is a sixth, and a fourth is bigger than a sixth, and there you go. And then, of course, we're back to them like, wait, you had that fraction, but you're not making the right connection. And then finally, equality. They don't regroup decimals the way they think that 0.4 is not close to 0.375, or that 3 is smaller than 0.3 is smaller than 0.30. And this goes back to the estimation where they need to be thinking about what that number represents. Therefore, when they take a look at 0.4 and they realize, wait, 0.4 is close to 0.375, and they make the connection there. So those are areas where there's challenges and therefore areas where we would need to correct. Now, one way is explicit instruction. Back to that number line, Sean. Well, yeah, but the number line again shows where they are in respect to the development. So for example, let's just take a look at these two. So one, using a number line that has well into the thousands to be able to see how incrementally going from 0 to 1 these numbers grow and how these numbers will be represented, right? Even though they're getting longer and even though the zero's there, the representation. The other, down below, is at 3 to 4. And so how there's increments of 3 all the way up to 4. And again, we were using these in fractions, so why would we not apply them over to decimals? And of course, beginning with hundreds, tenths, hundreds, and thousands with the base blocks, then to be able to associate with where they align themselves with the whole numbers, to then associate them to all the computational things that will follow. So that's just a brief overview of particularly the errors associated with how individuals think of decimals and how those can be very basic errors in terms of how they think of tens and hundreds and thousands. But then when you start getting into the computational elements, how that would be further complicated about how they see the decimal. And then finally, thinking about base blocks. And we're going to be able to get into some activities now, thinking about how to use base blocks from upper elementary to middle all the way through secondary with some of these tools that are out there. And the only limitation in my boat on that aspect would be the consideration of whether or not you have access to those via the technology tools you're using, particularly in terms of the Adobe Flash. But again, there are some apps and Chrome apps that allow you to use something similar to what would be Flash-based, although there are more Flash-based manipulatives in terms of base 10 blocks and others that are used to help with decimals that, again, if you have access, I'd urge you to consider there because it offers so much more variance, it offers so much more visual representation, it offers so much more practice and understanding for that student. Great, I hope this was helpful, and we'll check in here after the activity is completed.